Okay. So I said let u equal, is it encoding? Hello? U equal x plus 1, and then I asked you folks what u minus 1 has a value of. Okay. This is not traditional kind of thing. This is traditional to do that, but to do that second line is not very traditional. That's why I was like, what? I haven't done this in a while. I've forgotten about that sneaky little way of doing things. Take the derivative of u, and you get du over dx equals 1. So the antiderivative becomes the antiderivative of u minus 1 times the square root of u du. So you're looking at this going, what? Well, that's not easier. And I hit the pause button and I say, but it's not easier, but it's doable because you can do this now. U to the 3 over 2 minus u to the 1 over 2 du. So you just distribute the variable in, use your exponent rules. Okay, what's the antiderivative of u to the 3 over 2? U to the 5 over 2 over 5 over 2 minus u to the 3 over 2 over 3 over 2 plus c. So it becomes 2/5 u to the 5/2 minus, why would I do that? Why wouldn't I switch it back? What's u equal to? X minus 1? X plus 1. X plus 1 to the 5 over 2. 2/3 x plus 1 to the 3 over 2 plus c. And you're finished. I guess that would you argue that this is a very sneaky substitution technique? I kind of see the word reverse being used now, but it wasn't. I was like, why would you? What? It's not easier. It's doable now. Okay, when you can't do the first one, because there's like if you multiply the x into the brackets, it becomes this. And there's nothing that I can do for that. So that the key was the root. Let u equal the crap under the root always isn't a bad strategy. Well, not always. Most of the time, let u equal the crap under the root. Not always, most of the time. So if you use that rule here, let u equal the crap under the root. Then you look at it and you go, okay, but Mr. App, that gives you that so far, yes? So the problem is the numerator. I'll solve this little equation that you just made for x. What? -1. Well, I was going to do this. Is that what you said? Is that okay? So, what do you let du equal? So you've changed it from a I love how you say this. From an easy antiderivative to a, sorry, from a not easy antiderivative to another not easy antiderivative. Right? But, and I'm not going to skip any steps here. You can figure out each part. Haven't even made the test yet. I'll probably have to ask something like, I don't know about this one per se, but this technique I probably should. I think substitution is always asked. I don't know about this technique. I'll go flipping through Barron's and go look. So, antiderivative of each piece now, and when we're finished. So negative, open a bracket, add a whole to negative a half, you get 1/2. Divide by the answer, 1/2. Add a whole to positive a half, you get 3/2. Divide by 3/2. So you get negative 2u to the 1/2 plus 2/3 u to the 3/2. You know what I mean. Take out the u's, put in x's, and you're done. Yeah? Do you want me to put in the x's? No? Okay. What are you going to let u equal for the next one? So solve that for x. Oops, u plus 1 equals x. So what does the antiderivative become? And you're looking at it going, Mr. Epp, that's not any easier, is it? But it's doable. This isn't something that I would have thought about until I went, well, I got to deal with the root somehow. Two wholes plus a half is 5/2. 2 wholes, 1 whole plus a half is 3/2. Then you take the antiderivative of that and you're finished. Different? Yeah. Not an obvious thing. Okay. Antiderivative of x squared. Next one. Next one. No, it's not. You've done this. You just are so programmed into the power rule that you get sucked in and do it wrong. There's a function that when you take its derivative, you get 1 over x. Say ln. And then we force it to be positive. Yeah, absolute values. But if you look at it, I've set you up, right? Power rule, undoing the power rule, undoing the power rule, undoing the power rule, undoing the power rule. Nope, not that one, because when you undo the power rule, you add 1, you get x to the 0, and you divide by 0. Right? That'd be bad, very bad, very bad, very bad. Okay. The last one should have been a bit of surprise. Hopefully it wasn't. Okay, so the antiderivative of dx over 5x. So what I would do is take the 5 out front, 1/5, antiderivative of 1 over x dx. The antiderivative of that is 1/5 ln absolute value of x plus c. Can you see why there's a hyphen in that sentence in your notes? Because the next one read the hyphen. You know what the most common mistake is? Look at number 11. What do you think the most common mistake is? Yeah, 5, not 1/5. Because you pull the 5 out, right? But when you pull the 5 out, you're really pulling a 1/5. Okay, 13. Let u equal x plus 1. What's du? du over dx is equal to 1. du equals dx. So we get the integral of 1 over u du. What's the antiderivative of 1 over u? ln u plus c. ln x plus 1 plus c. What? Yeah, but u prime is 1. Okay, flip the page, dude. Nice leading exam. Nice leading question. Dylan, you're awesome. Everybody thank Dylan. Thank you, Dylan. Okay, what are you going to let u equal here? u equals x to the 4 plus 5. What's du equal over dx equal? It equals 4x cubed. Now, am I doing this way or Mr. Howell's way? My way or Howell's way? My way? He solves for dx, and I don't. I like to keep my x's together and my u's together. I don't like use an x as being mixed. Yeah. So I like to do this. Du over, so I just go looking up here and I say, okay, I see all of this, so I need all of this. So it becomes the antiderivative of 1 over u du. The du takes care of the 4x cubed, takes care of what you were talking about, Dylan. That u prime, that's what du is. It's u prime, sort of in a funky little way. Does that kind of answer your question? Yeah. Whoa, what are you talking about? I didn't say that. No, I didn't say that. No. Yeah, well, because if you look at the way that it's u is x plus y. Yeah, well, yeah. And then sometimes, because it's like x to the power of 4, that's a quartic, it's always positive. Well, it's not always positive, but this quartic's always positive, and you add 5, it's even more positive. You don't actually need absolute value brackets, you can just put round brackets and be happy. But that's... Okay, what are you going to let u equal here? So what's du over dx? 3. Strap, I don't see a 3. Okay, well fine. Take it over to the other side. Du over 3 equals dx. So the antiderivative becomes 1 over u times du over 3. Don't like the 3 there. Good. Take it out front. At 1/3 ln u plus c. How we doing? Is it a thumbs up? Sort of up? Pardon me? Pardon me? You find this stuff easier in chapter 4? Oh, okay. What are you going to let u equal here? 3x minus 2 du over dx equals 3. Strap, I don't see a 3 up here. When I say when I don't see a 3 up here, I mean I'm looking here for 3. Is that kind of clear what I... Okay. I don't see a 3 up there. So I read it as du over 3 equals dx. So the antiderivative becomes 1 over u squared times 1/3 du. Take the 1/3 out front. And then smile and realize we've done a whole bunch of ln questions. 1 over u, 1 over u, 1 over u, 1 over u, 1 over u squared. You don't need ln. You just write it as u to the negative 2 and laugh at me and say, you tried to trick me. It's only 1 over u that has an antiderivative of ln. 1 over u squared is not ln. Don't get sucked into that pattern. X leading me in. Veer off at the last second. Go, you tricky, you cheeky monkey. Add 1 to negative 2, negative 1. Divide by negative 1. So the answer is 1 over 3, negative 1 over 3u plus c, which is equal to... Oh no, what does this mean? It means you need to be careful. You need to look at your exponents before you take the antiderivative. Yeah? You need to be careful. Look at your exponents. Okay? Nothing worse than getting sucked in. What? Well done. If it doesn't look like any of your patterns, you have to break it up and do something else. What are you going to let u equal? So du over dx equals negative sine x. I don't see a negative, so take the negative with the du, put the dx with the sine. So the antiderivative becomes, this comes out, that comes in. This comes out, that comes in. You can always put a 1 on the top. That's and the antiderivative of 1 over u is? So the antiderivative of tan is negative. Now, do you know why I didn't do the rule for that one? Because tan doesn't, the antiderivative of tan is not an easy, it doesn't go back and forth easily when we learn. That's why. Okay. What are you going to let u equal? Good. The stuff in the brackets. What's du equal to? 1 over x. So du equals 1 over x dx. One-third u cubed. So it's 1/3 bracket ln x bracket cubed plus c. Okay, what are you going to let u equal? Du equals 1 over x dx. So you jump from here to here, huh? That's fine. Yeah. So it becomes the antiderivative of sine u times du. Antiderivative of sine, negative cos. that the page? Oh, one more. That's my hint. What are you going to let u equal? du is going to be so we'll skip to that step, okay? Now you have to see those there, even though they're spread apart. Know what I mean? I think that's a good place to stop. Tomorrow we will talk about e to the x. It's not an even. U? U!